Hey everybody, welcome to video 1-2. We're going to be talking about angles in this lesson. First page here, I am on page 19 and talking about constructing a copy of an angle. I want you guys to just put a big fat W-A-I-T with a circle next to this. We are going to do this, but we're going to do this in class so I can demonstrate it on the board step by step for you, okay? So you want to make sure you bring your compass and a straight edge to class tomorrow so I can demonstrate that and we can work on it together. It's really important that you do know how to do this construction because it's a smaller piece of a construction that we do later on with parallel lines actually. So we're actually going to start our video notes here on page 20, so turn the page. And this is, again, going back to the whole idea of how geometry is like a foreign language. Here is another very important building block in geometry. You can see what it's made up of here. An angle is a figure formed by two rays that have the same end point. So the corner of the angle is what we call the vertex or the common end point, and the rays are the sides of the angle. So if I ask you to name the sides of an angle, you're going to give me in symbols the rays that make up this angle. So here in example 1, part A, we have angle PQR, and notice how we have named that P to Q to R. It pretty much just kind of does a zigzag that literally outlines the space of the angle. We could go ahead and name it with 3 letters in the letters P, Q, R. When it's named with 3 letters, the middle letter, as you see here, is always the vertex. So the corner is always that middle letter. The sides of the angle are the rays, and notice since the common endpoint is Q, you're going to see Q repeated in ray QP and ray QR. So which corner does it join at? It's the letter that's repeated. And then we are going to draw, and that's just identifying the pieces. So the second part says draw and label the angle as shown. Part B here says we've got angle, notice we are going to name this angle. The vertex of the angle shown, we're going to fill in as we go here, is what corner. So if we're looking at part B of this example 1, K is in the corner of the angle. So K is going to go in the first box. A name for the angle then is we could just call it angle K. Back here we could just call it angle Q. And you could have an angle symbol look like this as you see written in the book, or typically when I write it in my notes I do this because it makes a little bit more of a distinction between an angle symbol and if you just made like a slanted L really quickly. I like to draw this arc that goes through the angle itself. So we could call this angle Q back here in A, just like we could call this angle K. And you'll see how I write that, okay? The vertex has to be in the middle, so let's put the K in the middle for both of these. But in this case, we could go LKJ, or we could reverse it, and we could go JKL, okay? So this one could not only be PQR up at part A, but it could also be angle RQP. Remember, the most important thing is just that the vertex is in the middle, okay? In this part B diagram, our angle is also numbered, and when you see the number, you're going to see it appear inside the space of the angle itself. So that is just going to be another way to name it. We just put the angle symbol and then the number. In this case, it's 1. All right? So what I'd like you to do is take a quick pause on the video here and do your turn number 4. You're going to name this angle below here. Name angle 2, this one, this space, in as many different ways as you possibly can. For number 5, it says use a compass and straight edge to copy angle BEC. Again, I want you to put a big fat WAIT next to that. That is one of the your turns that you're going to do after we walk through the steps of the construction together. So for now, for the video, just do your turn 4, okay? Okay, the next part of this video is talking about measuring angles, and you did this a little bit in your summer homework, so this should be a really quick review here. The unit of measurement for measuring angles, as you can see, is degrees. It is 1/360th of a circle because there are 360 degrees in a circle. And we write it basically in how much of a circle does it take up, okay? So an acute angle takes up between 0 and 90 degrees, not including either one of those endpoints, notice with the inequality here. If it's exactly 90 degrees, we call it a right angle, and you will see that square symbol right in the corner at the vertex of the angle. If it's an obtuse angle, then it's bigger than 90 but still less than 180, the measure. And then if it is a straight angle, it forms a straight line, so it's exactly 180 degrees. In example 2, you're going to take your protractor and you're going to draw some example angles here. So it's just walking you through those steps. You did measuring during summer homework, you didn't do actually drawing, so this is just going to walk you through that process kind of in reverse, really. If we want to draw, in this case, a 53-degree angle, like you see here in example 2, part A, step 1 is to first off draw a ray. So if we're going to draw from a point through a line, you want to make sure it's long enough that it's going to go to the gap of where your protractor would be. So your vertex is going to go right in the center circle of your protractor. So you want to make sure your protractor is long enough that it goes through the outside of your, the ray is long enough so that it goes through to the outside of your protractor. If you need to extend it, do that, because it's really important that you see part of that ray on the outside, because the outside of that ray is going to tell you where you're going to measure. Okay, so place your protractor, the circle or the hole in your protractor, or like the crosshairs of your protractor, right on the vertex, and then line up the line that comes out of that center right on the ray itself. It's called the edge of the protractor, basically. And then what we're going to do is we're going to go up from the small numbers, wherever the small numbers hit on the ray. So in this case, we have 2 sets of numbers. We want to go out to, or use the inside numbers to go around to 53 degrees. So again, the inside track, because that's where it starts at 0 and builds up. And we want to get to 53. So we're going to go out to, here's 50. I'm going to zoom in a little bit so you can see a little better. So we have up to 50. And then 53, you can go and use the outside tick marks to 1, 2, 3, and you can see that's where they put point Z to construct the other side of the angle. So zoom back out. And then wherever you put the point Z, you're going to connect the other side of the angle. It's pretty straightforward. Really the most important thing here is just making sure you read the right numbers. So just make a note to yourself. So again, 53, if we think of from the beginning, this is an acute angle because it is less than 90 degrees. So if you think of your Z, and if you were, for instance, to put the 53 over here for Z, which is wrong, but put an X through it so you know that. The reason that would be wrong is because if we connected all the way to there, I hope you can see that this is going to be an obtuse angle, and that's not what you want. You want to connect it so that it's acute and 53 degrees. So just make sure you read the correct numbers on your protractor, and that takes a little practice sometimes. Okay, on the next page, I do want you guys to do your turn 7 and 8 here, which is just walking you through finding the measure using your protractor. If your protractor is not working out because the angle's too small, don't forget to simply extend the sides so that it goes out to the outside of your protractor as you're measuring it. Okay, the last thing we want to do is construct an angle bisector, and I do want you to read through the steps on this, but we are again going to do the construction steps together in class tomorrow, constructing the angle bisector. But I did want you to take note of the explain 3 here, the definition of angle bisector, as well as the postulate that has to do with angle addition. So scooch down to the bottom of the page here. An angle bisector is a ray that divides an angle into 2 angles that both have the same measure. So the box here does not show an angle bisector necessarily. It just simply shows 2 angles that are what we call adjacent or next to each other because they share a side right in the middle. You can clearly see that the size of angle PQS is a whole lot bigger than angle SQR, right? So they are not bisected, okay? It's not an angle bisector in this picture. This over here is what we call an angle bisector. And the reason for that is because you see these arc marks drawn in the space of the angle. It's similar to a tick mark on a segment, which shows that the angles, or that the segment pieces are congruent. This shows you that the angle pieces are congruent. Another way to have them marked sometimes in the diagram is you'll see tiny little like tick marks drawn through the arcs themselves. Let me redo that, sorry. So if here is an angle bisector, then you might see tick marks drawn through the arcs themselves so that you see that they're the same size. So that's another way sometimes that you see them labeled. But what we would say here, as you're looking at the reading, is that the little m in front is the measure of angle AB to D. So ABD, the top half of that angle, is the same as the measure of the bottom angle, which is C to B to D, okay? And again, just like before when we were talking about 2 segments that made up a larger segment that were collinear, if we were to think about what are the repeated letters here, the repeated letters are BD and BD, so that means that's the ray that cuts through the middle, that's shared as a side of both angles. So the angle addition postulate is the exact same thing as the segment addition postulate in that we can simply summarize it as small piece, so that's the PQS, plus the other small piece, the small angle SQR, equals the big angle, or the sum of the 2. Okay, so this is the big angle, this is the small angle, and sometimes angles are marked with multiple arc marks or possibly multiple tick marks. But do you see here how they have different numbers of arc marks? That means that they are not the same size. But again, the 2 blue small pieces, no matter what measures they are, added together gives you the total, the big full angle from P to Q to R, because it's made up of those 2 smaller pieces. And actually angles can be made up of more than just 2 smaller pieces, but it's always basically all the small pieces together equals the big. And that'll just be adding up degrees and working with maybe even some algebra within that. So that's what you'll see in the practice problems, okay? But if we want to construct an angle bisector, again, I just want to talk you through these steps. We will go through them. So on the next page, if we're using a compass and a straight edge, the reason I love this construction is because you don't have to reset any of the opening of the compass like some other constructions. So this is the first one actually that we're going to go through together tomorrow. And this is cutting an angle in half, bisecting the angle, okay, into 2 equal pieces. It's really simple. All you have to do is put your compass point at the vertex and you arc through both sides of the angle. Okay, so you draw a pencil arc through, and then you keep your arc length, your arc radius exactly the same. You just pick your compass point up, instead of at M, you move it to P. So over here you can see this is a copy of that construction in step 2. but it's just putting a new step onto it. So you move from the compass point is at M and you arc through it to now your compass point is at P, and you draw an arc kind of inside the space of the angle, and then you flip your compass back and you put your compass point down in step 3 here. You put your compass point down at Q and you do another arc, so you have like a little X crisscross of arcs. And then what you've done is you've located a new point R, which is where those arcs will cross. And then you draw ray M through the new point R, and you have cut the angle in half. It's pretty easy. But those are the steps. We'll go through them, like I said, together tomorrow, and that's it for today.